Alright, so this is calculus interview assignment, and let's start off for the first question. So, the following two lines are parallel but not coincident. So r1 equals 3, comma 2, 2 plus t to the direction vector of 2, 1, and 4. And then r2 is 5, 8, negative 2 plus t to the direction vector t, 1, 4. So we're given a point on R2, and we have to find the point on B so that the line connecting those 2 points are perpendicular to both points. So now when we move to our worksheet, so I just did a quick sketch here, as you can see, of the two lines and then the point B and then how it's perpendicular. So we wrote down our equations and we know point B. So we have 2 points that we know are on both of these lines. So if we're given 2 points, we're not given the exact point of intersection, but we can use the cross product because we know that yields a perpendicular line. So we find the cross product and we come up with the direction vector of negative 10, 8, and 7. So now we know our direction vector. Now all we need to find is the point that goes, the value of t that would make this true, in the sense that going from this point to this point. So we need to find this point, which we can be found by finding the t values. So we put both equations of this line and then the perpendicular line into the parametric equations, and then we merge set the equations equal to each other, and then we solve for solve for s and t. So for x, we put into the parametric equation and we get 2 equals 10s plus 2t. Y, we get 7 equals 8s plus t. And then we get z equals 0 plus 7s plus 4t. So I use the x and the y coordinates, and so I use elimination. So I did the x equation minus 2 of the y equation. So that would cancel out the t values, and that would leave us with s is equal to 6. S is equal to 2, and then we sub the 2 back into our equation over here, and then we get t equal to negative 9. So now we can use any equation. We can use either the R1 equation with the t value, or we can use our perpendicular line equation with the s value. So I chose to use the perpendicular equation. So now I've already have the parametric equation for this. So I've plugged in my point. So x equals 5 minus 10s, which is 2. So our x value of this point is negative 15. Y equals 8 plus 8 times s, or 8 times 2, which gives us a y value of 24. And then z equals negative 2 plus 7s, 2, which our z value is 12. So our point on R1, or point A, is negative 15, 24, and 12. Question number 2 is, I thought it was a little bit more complex. So we're given these 4 vectors. So vector v equals 3a minus 2b, u equals a plus 4b, magnitude of a equal to 2, u is perpendicular to v, and the angle between vector a and b is 60 degrees. So we need to find the vector. For our worksheet, I have written out the equations, and since we know that vector v and vector u are perpendicular to each other, we know that the dot product of those 2 vectors is 0. So now we know that the dot product is equal to 0, but we can expand out the dot product. So 0 equals the dot product, which is 3a minus 2b bracket dot, or sorry, the 0 is equal to vector v dot vector u. So I've expanded out that, and I have gotten 3a dot a plus 10b dot a minus 8b dot b, and then as a final equation. And now I've expanded the dot product, because we know that the dot product is equal to magnitude of b times the magnitude of a times the cosine of the angle. And so 3 magnitude of a squared plus 10 times b times a times the cosine of 60, which is the angle, plus magnitude of b squared. So now I've rearranged the equation so that it's 8b squared plus 10b, and then I've also plugged in the value of a, which is the magnitude of a, which is 2. So 10 times b times 2 times cosine of 60 plus 3 times 2 squared. And now I got negative 8b squared plus 10b plus 12. And so this kind of looks like the quadratic formula. So what we could do is we could use the quadratic formula to solve, or we could solve by factoring. And since solving of a binomial or of a trinomial, we need to know something that multiplies to 96 and adds to 10. So the values is 16 and negative 6. So negative 6. So negative 8 times the magnitude of b squared plus 16b minus 6b plus 12 is all equal to 0. So now we can solve by common factoring. So we've grouped these two numbers together as well as these two numbers. So now we have negative 8b bracket b minus 2 minus 6 bracket b minus 2 is all equal to 0. And so we can simplify this because we have two brackets that equal the same thing, that are the same thing. So it's negative 8b minus 6 times b minus 2. Now we solve for this bracket, so we go through BEDMAS, and we can then find that b is equal to 3 over 4. And then over here, b minus 2, so we have to make that equation equal 0. So in order for that equation equal 0, b has to equal 2. And that is the magnitude of b. B can either be 2 or it can be 3/4. So question number 3 of this assignment is kind of a new question, but it's fairly simple. So as you can see, we have the equation of a circle, and then we have the center point and the radius, as well as a point on one end of the sphere. So we need to state the coordinates on the direct opposite side. And then we need to find the Cartesian equation of a plane that is tangent to the sphere at the point 2, 4, and negative 1. So let's take a look at what we did here. So, I don't know if this is clear enough, but I'm hoping it is. So, we've written down the center, we've written down the radius, and then we've written down the point that we need. So, first you need to find the direction vector, and then from there you can subtract the direction vector from the center of the circle to find the point on the opposite side. So we've used the point that is on the one side of the diameter, so that's 2, 4, and negative 1. So we subtract that, we subtract the center point from that to find the direction vector. Now we subtract this direction vector from the center of the circle, and that would give us our point on the direct opposite side of that. So our point on the direct opposite side is 0, 0, 1, as you can see here. So now we need to find the Cartesian equation of a plane that is tangent to the sphere at the point 2, 4, and negative 1. So we know from our equation of the circle that the coefficients are 1x, 1y, and 1z. So we need to find the d value that would make this statement true. So we have our point, which is 2, 4, and negative 1. So we plug those points in, and we get 5 plus d equals 0. So now we can solve for d, which, so d equals -5. So then we plug that equation in, so x plus y plus z minus 5 is equal to 0, and that is the Cartesian equation of the plane that is tangent to the point 2, 4, -1.